So we are now at our Unit 11, discussion about structured query language and how can we use database management system IDE. So when we say SQL, we are pertaining to our structured query language, which is split into four um, major categories. But for our particular subject, we will only discuss the two. The first two, which is DDL or data definition language, and DML, which is data manipulation language. When we say data definition language, okay, from the word data definition or defining data, basically these are commands that is used to create, alter, or remove our database objects or certain parts of our database objects. In our sample table here, you could see that the most common commands that you could see inside a data definition language category are create, okay, alter, and drop. So those are the three most commonly used commands. All the other commands here are commands that are used to support those three major DDL commands. We will be having examples on those commands later on. The second category is called the data manipulation language or DML from the word data manipulate. So basically, these are commands that are used to manipulate data. Okay. Those major commands are select, insert, update, and delete. Okay. We we also have certain commands that are used to filter out or um, provide a selection criteria for our query. Okay, as you can see here, we have operators, we have functions as well. Okay, but in general, data manipulation commands consist of the four that I have said, which is select, insert, update, and delete. The third category is called the data control language, which is used to secure our database. So it involves database access, user access, okay, and the like. We also have transaction control language, which is used to manage and control some transactions that help us maintain data integrity. Okay. When we say schema, we are pertaining to a group of database objects, which can include tables, views, etc., etc. In layman's term, when you say schema in a database, it's actually pertaining to the actual database name, which contains all of your database objects. Okay. We also have common SQL data types. These are the more common data types. We have numeric, character, and date. Under numeric, we have whole numbers, which are, for example, integer, long, tiny int. Okay. We also have numbers which has decimal places or floating point precision. We have decimal. We have float. Okay. We even have um, data format for money or currency, which is called money or small money. And then for the character, which supports characters or string, we have char. And then this L represents the number of characters. So it could be char 1, char 2, char 3, etc., etc. We also have bar char, which is almost the same as char. The difference between the two is that char is a format that is fixed size. Basically, when you say fixed size, it accepts only that particular number of characters. So, for example, you define your column as char 3, it needs to have 3 characters. It will not accept anything less than that. Okay. Whereas if you use bar char, for example, bar char 3, It's okay if you place one character, two character, or three character. So the positive side with bar chart is that when it comes to size, it tends to be smaller based on the amount of data that you place inside that particular column. Unlike char, which is fixed. However, char tends to be faster because we have already defined the size. When it when we are trying to query millions of data, char column will definitely be faster than a bar chart column because bar chart column you can compare it to a highway which has three lanes and then suddenly it becomes one or two lanes. That will introduce traffic. Okay, unlike the char data type, which wherein data tends to move either forward or backward. They are in their own particular lane. Okay. Further definition on SQL Server data types. So basically, SQL Server data types, for example, we are describing about a person. That person will have a name, birth date, weight, and number of children. Okay. All of these particular data falls into several categories. Now, the name can be text, the birthday are calendar dates, the weight can be decimal values, and the number of children are whole numbers or integer. Data types define the characteristics of the data that can be stored in a location, such as a database column. A data type defines the possible set of values that are accepted. For example, okay, a type of int, which pertains to integer. In SQL Server, if we are to define a whole number, we use int or int. It can only accept whole numbers. Decimal values are not allowed. Here's a listing of some people and their ages. So we have the name and then we have the age. Can you see the issue with the ages? They are all in an inconsistent format. Not only are they hard to read, but sorting and calculating the data is difficult. By using SQL Server data types, we can enforce the expected type of data to be stored, achieving a better result. Okay, so here's the same table with the ages shown as integers. As you can see, when age is defined as an integer, the expectation is data are entered as whole number. Once the system understands the data type, it can then sort the data in an order that makes sense as well as perform calculations. These are the reasons to use data types. Data is stored in a consistent and known format. Knowing the data types allows you to know which calculations and formulas you can use on the column. Data types affect storage. Some values take up more space when stored in one data type versus another, as I have told you in the example about char and bar char. Then data types affect performance. Okay. The less time the database has to infer values or convert them, the better. As again, as I have told you about char and bar char. These are the commonly used SQL Server data types. Take note when you are moving from one database vendor to another. For example, you are working from SQLite to SQL Server to MySQL. There are times that the data type will be different or the data type will not be accepted. So you have to check which data types can be transferred from one vendor to another. However, they do support all the data that you can enter. It just happens that there might be a difference in the particular name or data type used. Okay. So for SQL Server, these are familiar data types. We have int, we have varchar or nvarchar, we have datetime, decimal, float, and bit. For int, okay, The data type can store a value from, okay, so this is negative 2 billion up and to positive 2 billion. Okay. Practical uses of the int data type includes using it to count values such as a person's age or use it as an ID to a table. But int wouldn't be so good to keep track of terabyte hard drive address space such because the int data type only goes to 2 billion as we will need to track into trillions. If you are going to need bigger sizes for your data, you could use the big int. The int data type is used within calculations. For example, days to manufacture is defined as integer. We can easily calculate ours by multiplying it by 24. So this is an example data manipulation language which we will discuss later on. I just placed this in order for us to have an example on how DML interacts with our data type. Okay, as you can see, the column days to manufacture was multiplied by 24. Okay, then the resulting output is displayed as hours to manufacture column. Varchar and nvarchar for text or string values. So varchar stands for variable length character. We need to specify the number of characters to store in a varchar or nvarchar column. For example, in this particular example, we have the column name and then we have nvarchar having 50 characters. So it can store up to 50 character. What makes varchar popular is that values less than 50 character takes less space. As I have told earlier, space is allocated as needed. This differs from the char data type which always allocates a specified length, regardless of the length of the actual data stored. So if you, for example, use char, which has 3 characters, and then you inputted only 1 character, what happens is that it will still take up 3 spaces. Okay. The varchar data type can typically store a maximum of 8,000 characters. We use the varchar and varchar data type to store Unicode text because Unicode characters occupy twice the space. The nvarchar columns can store a maximum of 4,000 characters. Okay. The advantage nvarchar has over varchar is that it can store Unicode characters. One of the One of the examples that I can give you regarding nvarchar with regards to the uses during the time I was programming a website for a Korean company. So I was not yet aware of how um, Unicode characters are stored. So if you are going to store a language that is different from our Roman alphabet, you need to, or English alphabet, you need to use nvarchar. Otherwise, your database will not support the characters because usually Korean, Japanese, Chinese, Arabic characters takes up 2 characters in space. So one particular character from them takes up 2 characters from their English alphabet counterpart. So in order for you to support that, you need to make use of nvarchar volume. However, nvarchar can only store up to 4,000 characters. Date time. Okay. It is used to store the date and time. Okay, you could actually use date time to store date or time only. Okay, however, it supports both date and time. In newer versions of SQL Server, there's actually um, a date format and a time format, okay, that is supported aside from the date time. So you could use date for storing date and time for storing time, not just date time. Okay, so that you could save up on spaces if you want. However, from old versions of SQL Server, they use only the date time data type. For MySQL, you could actually use the date and the time data type already. Okay, decimal and float. So use both decimal and float to work with decimal values such as 10.3. They can both handle decimal points, however, they handle it differently. If you need precise values such as working with financial or accounting data, you use the decimal format. The reason for that is that it allows you to define the number of decimal points to maintain. Because in the decimal format, it actually accepts two parameters. The first one is the number of numbers that you could enter, and then the second one is the number of decimal places. So take note, for example, you define decimal, open close parenthesis, 12 4. You are pertaining to 12 numbers with 4 decimal places. So therefore, you can only use 8 numbers as your whole number, while 4 spaces or four numbers will be used for your decimal place. So that is how it works. Decimal data types are defined by precision and scale. A decimal data type can be no more than 38 digits. In the production.product table, the weight columns data type is defined as decimal 82. The first digit is the precision, the second is the scale. Okay. So this is our example. Float. Float are really good for long numeric values. Float rises to the top within scientific applications where extreme numeric values are encountered. Encountered. Okay. So basically, floats have greater accuracy than decimal. Bit is for Boolean or yes or no value. Basically, they accept three particular states or values: one, zero, or null. So one is true, zero is false. Okay, null is no value. So we also have an example here on how it is used. Okay, first is creating a table sample. So this is how we would create our table inside our IDE. Now, in the lecture that I have given, there's actually a step there on how we could install SQL Server Management Studio. However, as we know, not all of you has computer or a capable computer that can install it. That's why we will be using SQL Fiddle, okay, in order for us to execute our codes. Now, SQL Fiddle has differences and limitations. Basically, it is just web-based, and then we are actually working with a default schema or default database name. But most of the commands will work. Okay, so there will be no problem with that. You just have to um, familiarize with yourself with how we could use the database commands. Okay, so for our first example in creating table, we will create a table called table product. Okay, so we will now go using SQL Fiddle. So make sure that you have selected MS SQL Server 2017. Usually, the default is MySQL. So please select MS SQL Server 2017 as all of our examples in our current and future lecture will be based on SQL Server 20 SQL Server. Okay. So when you see this particular screen, it states that you need to build your schema or your particular database. So we must do that first. However, in SQL Fidel, it will not allow us to name our particular database. So for this example, we will just click build schema. Okay. Notice that after clicking build schema, it states that our schema is ready. So the first that we are going to try is building our own or making our own table. So in order for us to create our own table, we must make use of the DDL command create. So for our table, in order for us to create a table, use the command create table followed by the table name. Okay. So for this example, um, when we are creating a table, usually it is better if you have or if you are creating database object, it is better if you name them based on the type of object that you are creating. So in my case, I usually use the prefix tbl underscore followed by the table name in order for me to denote that that particular object is a table. Some users tend to just create a table in all caps. Okay? Some users use the prefix T, while I prefer to make use of TBL underscore and then followed by the table name. Actually, it depends on you. Sometimes I capitalize the first letter of my table name, but if you want to go with an all small caps syntax, that will be okay. So you need to find um, the format that is more comfortable to you. I do not encourage anyone to actually make all of your commands in all caps because for me that is not easy to read, as well as remember that in the internet etiquette, all caps means that you are shouting. Okay, so you could try to do a justified format or a camel case notation wherein small letter for the first word and then big letter for the next word, such like this one. Or if you want to go with an all small caps format, you can do this one. Okay. After naming your table, we must now put the parameters inside our table. So how do we do that? Of course, we make use of parentheses in order for us to put a parameter. However, your parentheses will be your starting and beginning point of your table. Now inside, our parameters will be our column names. So copying the sample that we have on our lecture, we have the following columns. So we have prod ID. So column name first, followed by the data type. Now, in SQL Server, if you are naming a column as a column that increases its value automatically, okay, we must put in the keyword identity and then followed by the numbers 1, comma 1. Now, this one pertains to your starting value and then your seed. Meaning, after your starting value, what will be added in order for you to come up with the next value. So when you enter first value, you will have 1, and then another value you have 2, so on and so forth. So this particular column, prod ID, will be our primary key. Okay. And then you could also make or define your column to have a not null property. Of course, because this is a primary key, it must not be null. Okay, it must not be null. So again, column name, data type, and then followed by all the other properties that you have. Okay, in this instance, our primary key will only be one particular column. Next, all the other columns are prod name or product name, which is varchar 50. I can tell here that it could be blank. If I do not want that to be blank, I will put not null. Okay. The default will actually be null. So for example, prod price is money. I will not place anything, so that will have a default of null. And then product date, okay, date time. Okay. We'll just copy this command. Okay. Our schema is ready. Okay, so upon executing our schema, so by the way, I will explain these two parts here. In this part, you this is where you will enter your DDL commands or data definition commands. Whereas in this part is where you will enter your data manipulation commands. Okay. So if you are to execute select, insert, update, delete, you will run it in this side, and then it will show the output on the bottom part. Now, for our PDL, if you want to double check the commands that you have made, you could click on the browser, and then you could check the commands that was executed, or basically the particular object that you have created. Okay. So for our example, just to show you how we could um, show the value of our table, first, because we have created a blank table, we will enter insert statement. So basically, we are going to enter three particular data. So we have high, and then we have who, and then we have who. Then the price 2, 3, 4. For the date, we have 12 and 14. Okay. Notice that at the end of our command, I use here a semicolon. So you could actually define a particular query terminator. Query terminator means that after that particular line, any command after that will be considered as a new command. Okay. So we need to tell our SQL Fiddle on where the command starts and where does it end. So we have here three insert statements so that we can have three data. And then we have here a select statement. Take note that after running your particular SQL, the table will be, the data inside our table will be deleted in SQL Fiddle setup. If you are using a database management system, it will be easier because all the data are retained. However, for this purpose, we are using this SQL PDL because it does not need to be installed in your computer. Now, after inserting data, we must display all the columns. So you do that by using the command select asterisk. So asterisk pertains to all the columns in your table, followed by the keyword from, followed by the name of your table. So let us try to run this particular command. So click run SQL. We're just waiting for it to be executed. And then notice after execution, okay, this will be the result. So that is how you would create your table and how we could show and insert the data inside our particular table. Now, I would like to show you how we will execute the same commands, but this time using the actual SQL Server Management Studio. So after you have installed your SQL Server installation, okay, you go to your SQL Server Management Studio. Basically, this is an interface in order for us to connect to our database. Now, you could either go with the Windows authentication, or if you are accessing your database in different location, you could enter the IP or server name and then the login and the password. Now, for this example, okay, notice that on your left side, this is called the Explorer window, where you could view all the objects that you have in your database in your SQL Server database. Not only the database but also the security, objects management, all the other stuff. For this example, we will go to our database folder. In your database folder, you have your system database as well as the user database. If you want to execute a command, you go to the new query or new query window. So it will open up a blank page that is similar to Notepad. What you can do is, if you want to create a new schema, you type in the command create database followed by the database name. So for example, this database will be called testdb. Then I will execute the command. Okay. If you refresh your database folder, we will have a testdb database here. Now, after executing this particular command, okay, you double click your testdb database in order for you to access all the objects inside. Then enter or select a new query window. So I'll just close this one because we have already created the database or our schema. And then in this side, select the database that you want to use. Okay. You could also actually use the command use followed by the name of our database. Use testdb. Okay. Just to make sure that you are using that particular schema, because there are times that you might get confused and your codes are executed in a different database, and then your boss asks where are your work, and because you have intermingled your work with other databases, it might provide or it might cause issues or problems, most especially if you are using a production database or the database is actually already in use. Okay, so be careful with executing query inside your database. Now, after our selection here, you notice that we could create different objects. So what we do is I will copy the command that we have created earlier. So I will make a table called table product with all the same specifications. Okay. Do not forget the semicolon. Then execute. After that, if you actually refresh your folder, it will contain the table product. Now, if I want to insert data, I could actually just insert the data inside the table, just like an Excel type um, entry. But of course, we will not do that. You are IT students, so we will insert our data one by one. Okay. So first, let me explain what happened here in when we are inserting data. When we are inserting data, we use the keyword insert into table name. Okay. This is one form. There are other forms of inserting data through code that I will discuss to you later on. But this is our first form of inserting data. After declaring the table name, you need to provide inside the open close parenthesis all the columns that you want your data to be inserted into in proper order. So take note, we made use of the definition null. It means to say we could actually just insert one column or two column values here. We do not need to enter data for all of them because we specified the definition of null. But if one particular column is defined as not null, okay, and then you didn't provide a data for that column, you will encounter an error. Now, the next question is, sir, why didn't you provide prod ID? Whereas you said that if it is not null, it is required to have a value. Yes, that is correct. However, take note that our prod ID is already has a default value, which is true identity. If you remember identity, we are telling that the column value will start at a particular number, and then each and every new entry we will add a particular value, which is in this case 1. So because prod ID already has a value, okay, we will not and we should not place it here anymore because the value will be dictated by the actual database system. Okay, so in this instance, we are inserting name, which is varchar or string, price, which is money or number. You could also make use of integer here or int or float or decimal. But because we want to signify that this is a currency or amount, we use money. And then lastly, we have prod date, which is date time. As I have said, you could also use date here because we are only inserting date. But if you want, for example, to add time, let's say, for example, to add a date and a time. Okay. So after doing that, what you need to do is if you want to execute your statement one by one or per line, or you just want to execute all the highlighted commands, just highlight the commands that you want to execute and then click execute. If you want all of them to be executed, make sure that nothing is highlighted and then click execute. So for this instance, I want them all to be executed. So notice that here all the affected rows, meaning we have inserted 3 rows. Now, If I want to display the output, make sure that you will not execute these three commands anymore. Otherwise, we will have 6 data. So highlight and then click execute. So there you go. Notice the second line contains a time. All the other data has a default time value of 12 midnight. Okay, or 0000 hours. Okay, so that is how you would use your SQL and your database IDE. Also take note, the proper pronunciation for SQL is actually SQL, but I do not want to read it as SQL. I want to read it as SQL because it stands for structured query language. But you could use SQL if you want to.